In our last video, we went through the TShark basics room and we covered the fundamentals of TShark by focusing on how it operates and how you use it to investigate traffic captures. We also went through display filters and capture filters. In this room, we're going to go advanced features, and we're going to be focusing on translating the Wireshark GUI features to the TShark CLI. And you'll see exactly how you can actually get all of the functionalities of the GUI inside of your command line interface, which is really awesome. I've already started our virtual machine and we are ready to go. This video is based on the TShark CLI wireless features room that is a part of the SOC level 1 pathway of TryHackMe. And as a part of this pathway, we have the network security and traffic analysis module. And a lot of these we recorded the first time that we went through the SOC level 1 rooms, but they added some rooms recently that I was notified by from our community. And so we're going to be going through all of these rooms that I have not done so we can have videos for them. And then at the very end of this thing, we have this massive challenge that's available to us as well. So very excited about going through all of this, and hopefully you will also find it useful. All right, one of the key Wireshark features is the statistics menu that you get access to that gives you a lot of really great information about the traffic that you've captured and about specific packets and dare I say transactions that are going on inside of that network. And the three important points that we want to talk about or keep in mind as we go through this is that these options are applied to every packet that is in the scope of your capture, unless there's a display filter that is provided to prevent those packets from showing up. Most of the commands that are seen that we're going to go through are CLI versions of the Wireshark feature that's discussed in the Wireshark packets operations room, which, by the way, all of those videos are also available on this channel. As long as you just search for Wireshark on our channel homepage, you'll be able to find all of those videos. And finally, TShark explains the parameters used at the beginning of the output line. So for example, if you use the PHS option, you'll view the protocol hierarchy. Once you use that command, the results will start with packet hierarchy statistics header. And this is just one of the parameters that we're going to be covering through. So the parameters are as such. So color, specifically -- color, is going to show a similar Wireshark-like colorized output, which I'm actually excited to see because I wonder what it looks like on a command line. Then we have the -z, which is giving us the statistics. So if you do -z help, of course, you'll get the help menu for that specific statistics option. And then the sample usage would be TShark -z filter. And every time that we filter the statistics, packets are shown first, then the statistics that are provided for those packets. So you can suppress packets and focus on the statistics by using the Q parameter. And then we can also limit our output, so on and so forth. So this, I guess, is exactly what it looks like as a colorized output. This looks identical to the Wireshark interface. This is actually really freaking cool. So this is basically TShark R, so reading the color PCAP file and then just using the color option just so we can see what it looks like colorized. This is freaking amazing. It literally looks identical to the Wireshark GUI, so that's pretty cool. And then we have the statistics protocol hierarchy. So if we do R demo PCAP, so reading the demo PCAP again, and then we just do -z to get our statistics. And then you have IO, PHS, and then -Q. So IO, in this particular case, I think it might be the interface, and then PHS would be the protocol hierarchy. So for example, protocol hierarchy statistics, you have the filter, Ethernet, IP, TCP, so on and so forth, and then the frames that are associated with them. And that's basically it. So we're going to go through all of those options just to answer the questions that we have in this room. So we're definitely going to get to use all these things in advance. And then we have our demo PCAP, so to actually read the file again, and then we're doing -z. And then this time we've added UDP because we want to see the UDP packets connected to our network capture. So the filter right here shows UDP. Over here, there was no filter that was attached to it. So the filter actually shows UDP, and then it gives you the information about the packets as far as the protocol hierarchy itself is concerned. And then packet length tree. So -z, and then we have plen for packet length, and then we have tree, And tree, I think, is just mostly showing the organized version of it. So the packet length tree view helps analysts to overview the general distribution of packets by size in a tree view. It allows analysts to detect anomalously big and small packets at a glance, and then you use that to view the packet lengths tree. So this is exactly what it looks like. It's just this very clean output compared to what we see over here. Very, very clean output that you have over here, including all of these the titles, I guess you could say column titles or field titles, so to speak, with the various values that are attached to it. So very, very cool, very useful. Oh, we actually have more stuff at the end here. So we have the burst rate, the burst start. This is very similar to what's available inside of Wireshark in general. So in the first video, they said that there are some capabilities that we won't get from Wireshark, but so far it seems like we actually get everything that is available inside of Wireshark as well. We have our statistics endpoints that allow us to view the unique endpoints that are available to us. So it shows you the number of packets associated with each endpoint. If you're familiar with Wireshark, you should know, or Wireshark, not Fireshark, you should know that endpoints can be viewed in multiple formats. TShark supports multiple source filtering options for endpoint identification. So if we use Z endpoints IP and then Q, we will be able to see that we can get Ethernet, we can get the IPv4 address, IPv6 address, TCP, UDP, WLAN, all of that good shit. Or excuse my French, good stuff. We have TShark reading the demo packet, using Z for statistics, and then now we want to see endpoints, IP, and then you see all of these pieces right here. So very, very useful information. And finally, we got, I don't know if this is actually finally, I may have been premature with that. So we have conversations. Conversations is basically what happens across multiple IP addresses, and you get to see the back and forth between those two IP addresses. And you have this right here. So these arrows are talking about there's a back and forth conversation happening. It's not just going to this, or it's not just coming from this. It's literally back and forth conversation that's happening. So you get to see the frames, the bytes, the start, and let's see. I think this has been kind of compressed, so you don't get to see the full amount of data that's going on over here, because these things, this portion of it is kind of like messing with our menu that we have over here. But I think it would start with the forward and the backward option to be able to go back and forth, and you have the total relative duration. So total relative duration, I would assume that's what we're seeing over here, because it's a little bit congested. But essentially a conversation is the back and forth conversation that happens between two IP addresses. So most likely you will see more than one communication going instead of just a single packet going from one to the other. You'll see a connection of packets, a series of packets going back and forth between those two IP addresses. And then we have expert info, which is very similar to comments that are available, as well as descriptions and notes and a lot of great things that you can actually use for analysis of the packets and the traffic that you got. So Z expert, and that's basically how you would get your expert info. And then so we have notes that are attached to this one in particular, and then we have the chats that are attached to this as well, and they are grouped and they have various protocols that are attached to them, for example HTTP, and then there's a summary description of what is going on for whatever packet or let's say series of packets that it is that you're looking at. So now we're going to use the write demo PCAP to answer the questions that we got, and hopefully we'll be able to pull it off in a without any errors, so to speak. So what's the byte value of this? What is the packet length? And what is the summary of the expert info? Demo PCAP to answer the following questions right here. And that is essentially what we got. So just like every other video that we do, I'm going to open this up in a full screen format just so it's easy for you to see. And then from here, I'm going to open this up in a new window. And then I'm going to drag this into my second monitor so I can still follow the instructions that we got, but just make sure that you actually get everything that you need on screen. So let me make sure that this is all good, and then we'll get started. All right, so first we gotta find our exercise file. So we are, let's see, we are in our home Ubuntu, and then we have the desktop, and they said that our files are on our desktop. So we're gonna go and find them, and they are inside of the exercise files folder. So there are our files. So very good. And let me just ls one more time just so we can see it. So we got that. Okay, so what we need, I think the first one that we're going to be looking at is the write demo. So this is the file that we're going to be looking at. And the first question is the byte value of the TCP protocol. And so based on what we've learned so far, there are two ways that we can do this. So number one, we need to actually read the file. So that's the first portion of this. And then what we're going to do is we're going to do the Z for statistics. And then I can do this, right? So I could do IOPHS for the protocol hierarchy, and I want to see what it looks like without Q actually. So let's see what that actually looks like. Okay, I mean the output of this is not that bad, so I wonder what it looks like with Q. So let's do that part and let's actually add Q. Let's see what that looks like. Oh, you know what? It's quiet. That's what it is. So quiet doesn't show you the contents of the packet. You just get to see the statistics. So this is our content of the packet. There's literally, or the content of the PCAP file, and there's this one packet, and then based on that there was, you know, this information. So if you do it in quiet mode, then you just get the information without the contents of the packet, which is very useful. Okay, so all right, now I understand what they meant when they said when you look at statistics it'll still read the file as well as that. Okay, so the question is asking what's the value of the bytes for TCP, and it's right down here. So it's 62. So I'm gonna go down here, and I'm already zoomed in, so hopefully you won't mind kind of a little bit of blurriness, because there's two forms of zoom that I can do. It's the one where I manually zoom back and forth, but then when I manually zoom back and forth, I can also do this double click on my mouse, and it goes like super zoomed in. And usually I just do the double click because it keeps everything nice and crisp. But when we're inside of the view for the virtual machine, I can't do the double click because I'm no longer inside a Mac OS. I'm inside of a Linux machine technically, and my magic mouse doesn't work with my double click. So I have to manually do the zoom. But that's so irrelevant. You probably didn't even need to hear all that, but whatever, now you know. Okay, so that was the first question that we had, which is the byte value of the TCP protocol. I want to show you actually the second way that we can also do this, because the version that we looked at right here is the IOPHS. So instead of doing that, we could actually technically just pull up information about the TCP protocol technically by filtering for TCP. So I could literally just do this and pull up that entire thing, and as my options at the end right here, I could just add the TCP like that, and it'll still, I mean, it still gives me the same exact information as last time. I just have the TCP filter on here, and if there was more traffic that was inside of this file, there would be a lot more data that would be printed onto the screen if I didn't use TCP. They would give me all of the other options for XML and HTTP and yada yada yada, so a bunch of other stuff. But in this particular case, there was literally only these 3 data points, so it just worked. But if you wanted to, you could do TCP, you could do UDP, you could filter for a variety of different protocols. So that was our question, and now we can move on to the next question, which is in which packet lengths row is our packet listed? So in which packet lengths row is our packet listed? It's like a funny question, but we know that there is also a packet lengths option for this. So if we would just read our PCAP file and then do it with, of course, statistics for this whole exercise, we're going to be doing that. So there was the plen for packet lengths, and then there's tree to just kind of show you the organized version of it. And then from there, we would just do it in quiet mode. And now we have all of this data, and we want the, since we have technically just one packet, yeah, I would say it's literally this one packet right here. So since we only have the one packet, it would be in the, what is it, 40 to 79? Was that be the, that's the answer, right? 40 to 79 probably? Okay, cool, yeah, there we go. Next one is, what is the summary of the expert info? So let's go get some expert info for our file, and we can do that using this very, very fancy Let me actually clear the screen real quick for you. We can do it by reading the file, of course, and then we would do expert after we put Z, and then just do that bad boy in quiet mode. And there we go. So connection established request SYN. And what was the question again? What is the summary of the expert info? So this is our summary. So I wonder if I need to do that entire, oh, actually, no, you know what? It goes to the second line here. So that's the summary. So we copy that, go over here, voila, boom, and there it goes. And now we're going to do the demo PCAP to answer the question, list the communications, which is conversations, and what is the IP address that exists in all IPv4 communication. So we're going to do a combination of queries that we're going to use. So we're going to do conversations, and then we're going to do IP, and that should just pull up all of the IPv4 conversations that we have. So let's run that, and what is it? It's called the demo PCAP. So let's clear this thing up, and we're going to read the demo PCAP, and we're going to do Z and conversation IP and do it in quiet mode. And now I need to see which IP address shows up in everything, and it seems to be this guy right here, 145.254.160.237, shows up in all the communications. So boom. What do you mean? Oh, defanged format, my bad. So defanged format. So if you already don't know, let's pull away from our screen here just so we can go into CyberChef real quick and get a defanged version of that thing. And we do that, and then we have the output, so we just got to do the defang real quick. So go right here, do defang IP address, drop that, and boom, look at that. You see the defanged IP, copy that, and then go back here, one more, paste that, blow. There we go, defanged version of the IP address. And we are officially done with our first task over here. So let us move on to the next one, which is the statistics part 2. This series of filters that we're going to be using is also covered in the packet operations room for Wireshark, or the packet operations video for Wireshark. And I mean, there's a lot of filters for just for statistics, right? So I feel like hopefully we're gonna go through all the other features that are available on Wireshark as well. But as you can tell, the statistics can get you a lot of detailed information. And so one of them, as we continue here, are the IPv4, IPv6 packets. Having protocol statistics helps analysts to overview packet distribution according to the protocol type. You can filter the available protocol types and view the details using p-type, protocol type, and tree. So using quiet as the parameter, just so you can see the stats, this is what you would see over here. And this should swipe a little bit more as well. So there we go. So the maximum value for the rate, the percentage, burst rate, and burst start. So that would be this, that would be this, this would be this, maximum value. Apparently, there's no minimum value here, so we're all good. And then you see the protocol types all together is 43, but then there's 41 TCP and 2 UDP. So that's going to give you the IPv4, IPv6 volume, so to speak, of how many protocol types actually exist. And if there was HTTP, if it was ICMP, all of those things would also be listed here. In this particular case, we just have these two. Moving on to seeing everything in a single view, especially when you're working with large captures, and a single command can help you. You can filter all IP addresses using the parameters given below. So you can get the IP hosts in a tree view. You can get IPv6 hosts in a tree view. And in this case, they're just looking at the IPv4, and this is what it looks like. So all of the addresses are 43. This address showed up 43 times. This address showed up 34 times, and so on and so forth. So all IP addresses in this particular case were 43 unique IP addresses from what I've gathered, right? So this is, I believe, filter all the IP addresses using the parameters given below. So yeah, that is what this option shows us. And then we now have the tree view for IP source destination and an IPv6 source destination. So in this case, IPv4 source destination, and this is what it gives you, right? Source IPv4 addresses. There are 43 of them. This is this, and then IPv4 destination addresses, 43 of them, so on and so forth. And it gives you the amount of times that they show up. And then we have destinations in general. I think that's what they're saying, right? So you will need to focus on outgoing traffic to spot the used services and ports. You can filter all outgoing traffic by using parameters given below. So destinations and ports. Yeah, so this is going to give us destinations and ports in a tree view, and then IPv6 destinations and ports in a tree view. And so you see this right here. Destinations and ports altogether are 43. And then you have this particular one. What is the port? Where's the port? Let me see where we can get that data, because for some reason it's missing. So let me see. Hold on one second. Oh, I see. So this is the IP address, and then this is the port for the one that showed up for this guy, I guess. So all of these ports, from what I understand, show up under this IP address for TCP ports. And then you have 3372, 3371, and then UDP ports 3009. And then we move on to this IP address, and it gives us all of the ports for that one. And so there are 22 TCP ports altogether. 18 of them are this, 4 of them are that, which adds up to 22 for this portion. And then we have UDP 1. Okay, that makes sense. So it's all dry. I feel like it's the view that we're in. I want to say that it shouldn't look like this, but we'll see how it goes. Do the same thing with DNS. So you can actually get DNS packets summarized in the available info. And as such, we have the total packets, R code, which is no error, op code, which is a standard query. These are our DNS codes that are available in this case. HTTP, same thing, right? So HTTP tree, HTTP2 tree, HTTP2. That's interesting. I wonder what that actually is, because they're not saying HTTPS. So I wonder what that actually means. So you summarizing load distribution, request packet status info. This is what you would get over here. And then you have HTTP load distribution for service or server, maybe service or server. Then you have the requests view, and then you have the requests and responses view, which would be used with the sequence acronym. This is just REQ for requests, and then this one is server for load distribution, HTTP, HTTP2. So what we have is just a regular HTTP view. You have the total number of packets, the response packets, 200 anything would be success. So the actual stat itself or the response itself was 200, and there were 2 of those. So this is all right here. And then broken, 0, 300 redirection, 0. We're missing the rest of them, but there should be 2 other packets because we only see the 2 for the success packets, and the rest of the data is as such. So now we're going to use the demo PCAP file to answer these questions. Which IP address has 7 appearances? Enter the answer in defanged format. So we got to use CyberChef. And then which destination address percentage? What is the destination address percentage of the previous address? Which IP address constitutes 2.33% of the destination addresses in defanged format? And what is the average queue name length value? So all of that good jazz we're about to find from our interface here. So let's zoom in on this thing and let's get some query writing happening. All right, the first question was which IP has 7 appearances. They didn't mention whether it's source or destination. So what we're going to do is we're going to get all of the appearances of all of the IPs. So we're going to be reading the demo PCAP file. We're going to read it with the statistics view. And what we want is IP hosts. And then we want the tree view. And of course, we want it to be in quiet format. And so this is what we got. And 7 instances would be this guy right here. So we're going to copy this thing. And then what we're going to do, let me see if I can go here and just scroll up and paste that and then scroll back down and copy that. And that would be our answer in defanged format. Boom, there it goes. What is the destination address percentage? of the previous IP. So this is this destination address percentage. Okay, all right, there we go. That's what we need to do now. We need to change this for destination address. So let me first find, actually, all right, here we go. TShark, whoops, typing on the wrong screen. Look at me, losing my mind here. All right, here we go. Okay, and -1 is incorrect, so we want to do -q. There we go. All right, so these are all of our destination addresses, all in all. And actually, I think this one is also showing me destination ports. So I wonder, yeah, I wonder if I can show, yes, I can. Yes, I can. Okay, so I'm going to clear up the screen. All right, so to find our destination list, we're going to read, again, this file. We're going to read it in statistics format. And what we want is the, I believe it was IP SRC for source, and then DST, not DEST, DST for destination, and we want it in tree in quiet format. So there we go. Now we have all the destination IPv4 addresses, and what the question was, destination of the previous IP. So 5999 destination percentage would be, yeah, so it's this 6.98, including the percent, I guess, right? 6.98%. Yeah, there we go. And which IP has 2.33%, which is this guy right here. So we're going to take this one. Oh, Control C doesn't work. Or I guess Command C doesn't work. Go here, paste that, and then come down here. Copy that. And boom. Cool. And what is the average QName length value? Okay, what is the query that's going to give us that QName length value? Okay, so from what I've gathered in our little hint was that it is a DNS value. So we are going to read our PCAP, and we're going to use DNS tree, and then we're going to use it in Q. And so now what we want is the QName length value. So let's go up here and see where that actually falls in for our average. And where is that information? Ah, there we go. So this is the QName, and so I want to say that this is the average. So let's see how this actually plays out. So we have the topic and the item, and then you have the count, which is the next one. The average would be the third one. So topic or the item, the count would be this, the average, and no, this is the percentage. So what is going on? I think I need to zoom out here and expand on this window. Yeah, see, now this gives us a little bit more organized of the data. So average is actually this field, and so now if we go down here, we'll be able to find the average of the QName length. So let's go find that thing. There we go, QName length 29.00. There it is. Sweet. All right, we are officially done with this particular task. So let us now move on to streams, objects, and credentials. Before we move on, I gotta give a shout out to the Hackaholics Anonymous membership community, the premier membership community that is inside of YouTube for security professionals and hackers. And I would really love this community. The people that are in there are very supportive of each other in the Discord chats and just in general, really, really cool people. We have some really great perks that are attached to this community for all of the 4 tiers. I highly recommend you check it out. And a big thing is I really would love it if you actually watched the video to see what the perks are, or you click on this little read more and then you go in the description of the video and then you read the description down here just so you can see what the perks are that are attached to each level. It's very important to me that you understand what you're getting yourself into, and I don't want anybody to have buyer's remorse. I don't want anybody to tell me that I didn't tell them anything, because I've actually gotten people to tell me that, and I'm like, yo, the description is literally right here, bro. Everything that you would get is actually listed inside of this. So it would mean a lot to me for you to check this out, and I think you'll get a lot of value out of it. So it might be biased and it might be you know, me believing that I'm drunk on my own punch or whatever it is. But if nothing else, I think it's good for you to know that this exists. And if you are ready for the future reference, you can bookmark it so that you can check it out for later. All right, that's all I got to say about this. Let's continue with the rest of our video. All right, now we're getting into some of the more nitty-gritty stuff. There's a lot of good things that you can get from Wireshark. It's not just random statistics, right? So and I guess none of those things were actually random. So I don't want to take any steam away or any credit away from what we just discussed so far. But Wireshark, as the reason why it is the most premier free open source network sniffing tool, gets you a lot of good information. Now, a stream is a traffic stream, right? So essentially stream is the best word that I can give you. It's a stream of traffic, right? So it gives you data about a lot of packets. Instead of looking at individual packets or a few series of packets that would be a conversation, it is a stream of packets. So it could be TCP packets in its entirety. It could be UDP packets. It could be HTTP or HTTP2 packets. And you can view them in hexadecimal or AC mode. And then there's the stream number that comes out, and then you have the quiet parameter to keep it quiet for you. So if you do follow, and then follow the TCP stream in AC mode, and then you look at 1, which I guess is the stream number, it will give you everything that is relevant to the first stream, and it will show it to you in AC format. So the nodes, which are the IP addresses, node 0 in this case would be the source, and a node 1 would be the destination. You have a GET request that's been made against a web page, and then you have the host being the actual Google syndication. You have the HTTP responses. You have the content type. If there were any payloads or any attachments, you would be able to get to see that. And then, of course, there's a hexadecimal that is also available if you wanted to look at it, but this is what AC looks like. And usually the payload inside of the AC is much bigger. So if you see a large portion of kind of random code like this, there's a lot of good intel in there. And you just gotta kind of build an eye for it, because the first time that I looked at it, I was like, what the am I looking at? This does not make any sense. But eventually, after seeing a few of these and then seeing what is the info that you need from them, which I'm pretty sure they're going to ask us to do for the questions here. After you see a few examples of this, you'll be like, oh, okay, I kind of see how to find the intel in there. So this is an example of what it would look like if you're just looking at a TCP stream, the first one in the list. Then you have export objects. So there are objects that are typically attached to streams. And it could be DICOM, HTTP, IMF, SMB, server message block, TFTP. There's a variety of different protocols that you can export objects from. And objects could be attachments, right? So the query is very simple. Export objects, as the name implies. You choose your protocol that you want, and then the folder that you want to export that file into. So for this particular case, you still read the file. In this case, they didn't use Z for statistics or anything like that. They just said export objects, and they want the HTTP objects to be exported. So there's a space between these two right here, which is very important to understand. There's a export objects, as you see right here, there's a space between them. And then you want the HTTP objects exported. You want them to be exported to a designated folder. And then you want it to be in quiet mode so that it doesn't print all of the data onto the screen. And then when you actually go into that folder, you will be able to see that there are 24 objects that have been exported. And then you get to see what the actual name of the thing is. And usually you'll find shit like this, which is this is all one object. And it's very kind of jargoned up, like congested or whatever, mumbled together. And then we have simple things like the download.html file. You can then look at credentials. See, this is where it gets really interesting, right? So credentials will actually give you, if it hasn't been fully encrypted and hashed out, it'll give you the credentials that are found inside of that traffic or inside of that specific packet. TShark, read the credentials PCAP, and then give me the credentials in quiet mode. And this is accompanied by the Z option so that you can look at statistics. And then packet, protocol, username. And then if we actually get clear text traffic, which is, I mean, I can't imagine there would be too many locations, but I've heard other people tell me inside of the world of cybersecurity that, you know, you'd be surprised how much clear text traffic actually still goes back and forth. There's actually a job that I'm currently interviewing for that it's for a pen tester, super excited about it. And they tell me, they're like, yeah, you'd be surprised how many of our clients actually still have clear text traffic that's going through in and out of their network. So I guess it still happens, but I'm like, dude, what are you talking about? How's that even possible? Anyways, use the demo PCAP to answer the questions. Follow the UDP stream 0. What is node 0's value? Enter the answer in defanged format. HTTP stream 1, refer value, defanged format. And the credentials PCAP to answer what is the total number of detected credentials. So that's what we got. So let's go into our file over here. I'm going to keep it in this view, so hopefully it'll actually be kind of useful for us. But let's see what it ends up looking like. So we'll clear this bad boy up, and these are the files that we want to analyze. Let's zoom in a little bit more here. Let's kind of get this centered. Okay, cool. All right, the first question was we want, gosh, what was it? We're going to be following the UDP stream 0 for the demo PCAP file, and we read the file as such, and then we got to do it in my keyboard, or the computer is falling behind my keyboard because I'm typing so fast. So we're going to follow this, we're going to follow UDP, and then we'll do it in ASCII format, and then we're going to do stream 0 at the very end of this, and then we're going to make sure that we do it in quiet mode, just to make sure that we have all of the data that we need. And let me make sure I don't mess this up by clicking around too much. And we'll drag this guy a little bit more centered here. Okay, so here's our info. And now the question here states that what is node 0's value? And this is node 0's value. So we're going to copy node 0. We're going to go defang node 0. And we're going to get back node 0 and go and paste it. There we go. Huh. Is that incorrect? Okay, so I think I'm supposed to actually include the port at the end of it as well. So we're going to go copy that, and we're going to defang it, and we're going to copy this, and let's make sure that we actually have. Okay, there we go. All right, HTTP stream 1, what is the refer value in defanged format? So same thing for demo PCAP. There it is. Oh my God, look at all this data here. This is insanity, craziness. So what is the refer value? Let's find the referrer. All right, here we go. It's towards the top, and we have refer HTTP, so on and so forth, and it has the download HTML file. So we're going to copy this, and we need to go defang it because this is a big one. So I'm going to zoom out of this right here, and I need to do defang URL as well. So you can have multiple recipes inside of Wireshark, CyberChef. And once you have multiple recipes, it'll just detect whatever the input is and then give you the proper output format, which is in this case a URL. So we're going to get that URL, and we're going to go back here, or not here, we're going to go here, and we're going to paste it, and that should be good. Excellent. And now we're going to look at the credentials PCAP to answer the question, what is the total number of detected credentials? So let's go do that. And we're going to read it, very similar to everything else we've done so far. And we're going to look at statistics, and we want credentials, and we want it in quiet format. And let's see how many credentials we get. All right, so we have a lot of credentials, and there's a lot of versions of it. I wonder if I can do count line. I think it was NL to count the lines. So let's see if we can rerun this and actually count the lines so we can see how many of these things there are. Okay, so I was pretty close actually. I need to pipe the response into the NL command so that we can get the number of lines that are counted. And so the big piece is that we're supposed to exclude these three, right? So, and the one at the very end as well, because this is considered a line, that's considered a line. And we want to start from this one actually. So we exclude the top three and then we exclude the one at the very, very bottom. So it should be 75 from what I understand. And there we go. That's what we got. So excellent. So this is a really, really freaking useful option. I really love the fact that you can just learn these things as you go along. So TShark, all that stuff, write the credentials, everything's all good. And then you pipe the results into the NL command so that it will count it for you. And I think you may even be able to use the NL command. Let's see if that is indeed the case without piping it. So if I just do that, it doesn't. So you need to pipe the results into NL, because if you don't, it's going to assume that you're trying to run NL from TShark, and TShark doesn't have NL as an option. So you would run that, and then you would just pipe it at the very end into NL, and then it will give you the results that you need, meaning it will count all of the lines for you. So number line, NL number line, is how you do that. And we got the result, which is 75. So all good here. Let us move to the next portion. Or sometimes you don't exactly know where you're looking. You don't know exactly what you are even looking for specifically. So you want to use something like the contains option or the matches option. And this is again inside of the Wireshark packet operations room. And these are just some of the ways that you can search for data without knowing exactly what you're looking for. So Wireshark has something called the find option. So if you say, just find me anything that contains the word Google, and it'll try to find that information for you. It'll probably be a lot of results, but it'll try to find that information for you. And it search inside of the packet. It'll search inside of the actual packet contents. And it is case sensitive, so that's very important to know. Matches searches for a pattern inside of the packet. It supports regular expressions, really freaking useful. Case insensitive, excuse me. And in this particular case, complex queries have a margin of error. So if you create a really big regex pattern that's fairly complex, it may not work for you. So if you have not seen the regex video, I would highly recommend you check out the regex video. We may need to create some regex patterns as we go along. So a couple of notes here. The contains and matches operators cannot be used with the fields consisting of integer values. So if there are fields that only have numbers as their values, it's not going to work. It only works for string values, which is alphanumeric, words, etc. Using hexadecimal and regex values instead of AC always has a better chance of a match. So using hexadecimal and regex instead of AC always has a better chance of a match, because as you saw, AC was like a very, there was just randomized letters in there and numbers and things like that, just randomized patterns and characters, and it's kind of hard to make sense of those things. So it would be best if you used hexadecimal and regex instead of AC. So extracting fields would be used with the T fields. So for example, E field name, and then showing the field name E header Y. So for example, you can filter any field by using the field names like below. So you would do T, capital T, fields, and then you want to extract IP source and extract IP destination, and the E header, which would actually show you the header. So in this case, you want TShark to read that file, look at the fields, extract these two for me, and then show me the header. So this is the header in this case, and then count to 5. So basically show me the top 5, but actually show my header, right? So IP source, IP destination, this is all the stuff on the left is IP source, this is all the IP destination. Otherwise it'll just show you this information. There's another trick to this, that like whatever your first option was would be the first column, and then whatever the second option is would be the second column. So if you don't have the header, you may you could still figure it out if you just understand that whatever your first choice was here would be the first column, this would be the second column. Then we have filtering anything that contains data. So comparison operator can be used. Description would be searching value inside of packets, as we already saw. It's case sensitive, provides similar functionality to the find option. You can find all Apache servers, for example, and you would list all the HTTP packets where the server field contains the Apache keyword. So it would be read the demo PCAP file, search for HTTP server contains Y Apache. So this is the piece right here. So where's the parameter? I guess it's actually Y would be the capital Y would be the specific option that allows you to put whatever you're looking for inside of quotations, and that'll serve as your search function or your contains function. So capital Y, single quote, http.server, which is the actual field name. So you need to know what field name you're looking for, and contains, and then double quotes, Apache. And it's case sensitive, so you need to be aware of that. If it was lowercase a, most likely anything else that has capitalized A in it, it would not show, right? And so you got 38 in this particular case. Read the file again, contains Apache T fields, so all of the stuff that we just did right here, right? So extract the fields for me, etc., etc. So T fields extract the IP source, extract IP destination, extract HTTP server, and show me the header. And so you have IP source, IP destination, HTTP server, source, destination, server, right? So you can combine the queries together to create one giant query, right? Then you have matches. So regular expression patterns, case insensitive, find all .php, .html pages. For example, you could list all HTTP packets where the request method field matches the keywords get or post. So HTTP request matches get or post, and this specifically is a regex type of a pattern. So you do same thing, right? HTTP request method is the actual field name that you're searching for, matches this specific regex pattern, and so you will get all of these results right here, and you actually get the data that is inside of it. So HTTP, get, so on and so forth. And you can combine that with your extraction, where you would get, I want to extract the IP source field, IP destination, the actual request method, and I just want you to give me a header for it. So source, destination, and the request method, right? So useful, really, really freaking useful. And once you get a hang of this, it's very useful. So using the demo PCAP file, we're going to answer these questions. What's the HTTP packet number that contains the keyword cafe? And we're probably going to be looking for a capitalized cafe. And filter the packets with get and post requests and extract the packet frame time. What is the first time value that has been found? And we want the, it looks like the actual date as well as the timestamp inside of it. So that's what we are looking for in this situation. So let's go and zoom back in here and let's do some work. Okay, so I had to do a little bit of Googling to try to find out where that word cafe would actually come in from. And I think it's the HTTP request URI. So let's try it out. So it's going to be TShark read the demo file, and then you're going to look for, so we do capital Y, and we're going to do http.request.uri contains cafe, and let me just make sure you actually see the rest of this thing. Contains cafe, and then what we're going to do is we're going to, I guess I'll do all of the fields. I'm kind of like jumbling up a few things together just to hopefully make the results come from. And so we need the frame number, which is what we want, and we also want the http.request.uri. So let's see if this actually works. And it doesn't. Oh, you know what? I need to do case sensitivity. That's the part that I was missing. I need to do case sensitivity. Sounds like I need to take a HR course or something. Huh, nothing still. Okay, so let me see. I'm just gonna modify this in every way that I possibly can and see what I can pull from here. All right, so it seems that I may have overcomplicated this. The biggest part about this that I couldn't find was the essentially the field that I was supposed to be searching through, which I guess is in this case the server is what we're trying to find, and it's going to include cafe. So that part, that was really the hardest part, was like finding the HTTP server. And so now hopefully the rest of this will actually work. So let me just make sure that I have enough of a space. And so we do T, we're going to do fields, we're going to extract the frame number, which is the packet number itself. And then from there, we're going to also extract the HTTP request, or the HTTP server portion of it. I just want to make sure that I actually get that data onto the screen, and hopefully it actually gives me the information that I need. So let's see if this actually works. And it does. So I mean, it's packet 27, and then cafe portion is the HTTP server name. So 27 would be the field. Yeah, okay, cool. Yeah, the hardest part for me was like, dude, I don't know what exactly I'm supposed to search for in this case. And it's the HTTP server field that we're trying to search for. So there we go. That's it for demo PCAP. That's what we were looking for. And now filter the packets with the get and post request, which is matches, is what we're going to be using instead of contains, and extract the packet frame time. So that is the next one that we're going to look at, and we're going to try to find the exact time stamp in this particular case. So let's see what we can do here. I'm just going to start the same way. So I'm going to read this thing. I'm going to do my Y, and I'm going to read for the HTTP request method is what we're doing in this case. And it's going to say matches because we want to use a regex expression, and we're going to put it inside of these parentheses, very similar to what we saw in the example itself. So that's what it's going to look like. And you have to close that out with that final single quote. And then we're going to extract the fields, and we're going to extract the, I want to say frame time is what we're extracting. And I think that's it. And then actually, let's try to do the E header portion as well. So equals yes, and let's see what we got. So frame time, there you go. Frame time for all of these things, and the first frame time is the one that we're looking for, which is this thing right here. So this full thing is what I'm gonna copy, and let's see if this is actually, hopefully that's right. Okay, nice. Whew, okay, all right, that one's cool. We got it. That was great. Very, very excited about the fact that this actually worked. I spent a good amount of time on those two questions, mostly because of the fact that I had no idea what the freaking thing was that I was looking for, the HTTP server, but a lot of trial and error in that one. So that is a wrap on that one. And finally, let's go through some use cases to extract some information here. When investigating a case, security analysts should know how to extract host names, DNS queries, and user agents to hunt low-hanging fruit after viewing the statistics and creating an investigation plan. The most common 4 use cases for every analyst are demonstrated below. If you want to learn more about this stuff, you can go through the Wireshark traffic analysis room, and that is also a video that already exists on this channel. So extracting host names. So we're gonna read the host names PCAP probably. We're gonna do T fields, and then we're gonna extract DHCP option host name. This is like the hardest part. If you don't have a cheat sheet for the various field names, that's the piece that is like a really, really big deal. So going through the Wireshark documentation is what will help you try to find the data that you're actually looking for. So this one is going to help you extract the host names, which is DHCP. In this case, there are a variety of different types of host names or host name fields. So DHCP option host name, and it will print all those for you. DHCP packets specifically, however, the output are hard to manage while multiple duplicate values exist. A skilled analyst should know how to use the native Linux tools to manage and organize command line as shown. So again, same thing. You're going to read through the same thing, and then you're going to pipe it into the AWK awk NF, and then you're going to pipe that into these various things. So sort R unique count, and of course sort R again. And it'll give you all of the unique instances that show up and give you an actual count for all of them as well. So now the output is organized and ready to process. The logic is shown below. So this is the full query right here. You're looking at the main query itself, and it extracts the hostname values. awknf removes any of the empty lines, okay? Sort R recursively sorts before handling all of the values, okay? Unique C shows the unique values but calculates and shows the number of the occurrences. So it actually counts all of the unique values for you. And then sort R again is another sort of this. I mean, it's literally same command, except you're just piping. So you're piping this into this, then piping that into this, then piping that into this, and then piping that into this. And the final sort process that shows you the output results from the high occurrences to the lowest occurrences. So going from the descending, I want to say, if it's going from highest to lowest, right? So TShark for DNS, same thing. DNS queries, T fields, DNS query name, and then you're going to remove all the blanks, sort, unique count, sort again, and then it goes from highest to lowest. Extract user agents, same thing. Literally the same thing, except you're just looking at the user agents and then extracting the user agent field. And in this case, we were extracting the DNS query name. And those were the lowest hanging fruits, so to speak. So what we're going to do is we're going to use the hostname PCAP and the DNS queries PCAP and the user agents PCAP to answer these last set of questions, and we'll be done with our exercise. So let's make sure that we are zoomed in so you can see everything that's going on over here. And let's get these last series of commands going. All right, so for the host names, we're going to be essentially duplicating exactly what that command was, and then we're looking for the unique number of host names that show up, and then the count of the prus PC, or I don't know what our prus PC probably. We're gonna get the count and then just find all the unique host names. So I'm gonna type this whole thing out first, and then we're gonna look at all of our results. There you go. So TShark reading the host names, extracting the fields. The field specifically that we're looking for is the DHCP option host name, and then we're going to pipe that into the removing of the duplicates, and then removing of the blanks, my bad, and then sorting, and then unique count, and then sorting again. And so we got that. And so all together now we want, what do we want here? What is the total number of unique host names? And this is actually something that I need to pipe one more time. I think I could do this. Let's see if hopefully it works exactly the way that I would want it to work. So if we just pipe that into the NL, the number line count, there we go. So it actually shows us all of the stuff that we previously had as well, except now it just numbers the lines for us. So we actually have a count of everything that's going on. So the total would actually be 30. So let's run that. And that is true. So what is the total appearance count of the PRUS PC? So let's try to find that guy at the top right here. And there is 12 count of PRUS PC. Very good. So very good. That's what we got. Now we're going to look at DNS queries and the total number of queries of the most common DNS query. So total number of queries of the most common DNS query. And let's type this thing out. Let me just clear the screen here. Okay, the highest count over here is 472 of DB Rhodes EDU. So 472, which is a lot. That's a lot by a giant margin of the second one. So now looking at the last set of questions. So user agents, to answer this question, what is the total number of the detected WFuzz user agents? And then the HTTP hostname of the Nmap scans. Enter the answer in defanged format. So first and foremost, we're going to read it, and then we're going to see the total number of the detected WFuzz user agents. So let's clear our screen here, and we're going to read the user agents. Okay, here we go. So the WFuzz is saying what is the total number of the detected WFuzz user agents, and what is that? So we got 9 up here, and then it doesn't seem, I don't think there's any more of those except this one. So we have 9 and 3, which is 12 as a total. So let's see if 12 is actually right. And it is. Great. So what is the HTTP hostname of the Nmap scans? So there is going to be an Nmap scan in here somewhere. So we want to find the HTTP hostname of that. And so we got Mozilla scripting https nmap.org. That's the only one that I can see, because everything else is SQL map and so on and so forth. So nmap.host, what is the actual thing, which is right here. So we're going to copy this, and we're going to go and defang it. And this should be our very last answer. So let me zoom out, because usually, oh no, that's actually, I got to do that before I hit conclusion. Oh, that's not it. Okay, let me see. All right, so for this one, we're literally going to repeat the same exact thing, except we're just extracting one other field, which is in this case going to be the HTTP host field, so that we can get that final piece of information. So it's going to still be the user agents file, and we're still going to do the T fields, and we're going to do our HTTP user agent. And then we're also going to extract the, what was it? I think because they gave it to us in our host, in our hint. It's http.host. That's the one that we're going to finalize and extract. And then from here, we're just going to sort through all the data using the parameters that they gave us. And this is super useful. Honestly, I feel like I'm going to refer back to this myself. And then, my God, I can't type. And one final sort at the end. There we go. We got all the data. Great. So now the one that we wanted, and I got to zoom out and I got to kind of organize this a little bit just so I know what I'm looking at here. The one that we wanted was for the one for Nmap. So there we go. Nmap right here. And then we got this piece right here. So I don't know if they want everything including the port, but we're just going to take the port 2, and we're going to copy and paste that, and we're going to copy this, and then we're going to come right here, and we're going to paste that. So maybe they don't want the port. So let's take that, and okay, cool. They don't want the port. They just want you to have the IP address without the port. So that is it, I believe. Let's see what the conclusion says, but I think that's it. I think we're done with this lab. Yep, we are officially done with this lab. So congratulations if you hung out all the way to the end. You are an absolute champ. And we're making some really good progress. So we're almost going to be done with this entire pathway. We were done once, but they added more rooms. So we'll probably come back when they add even more rooms, because TryHackMe updates all of their paths so that they can stay current and they can give you as much value and information as possible. So hopefully you got a lot of value out of this one, and you actually kind of tagged along as we went through this whole thing. So super, super exciting. I really loved it. I hope you did too. If you did get value out of this video, I do encourage that you like, subscribe, and turn on that notification bell so that you get notified the next time that a video comes out, because we're still going to be progressing down the SOC level 1 videos until we wrap that, and then we're going to continue with the SOC level 2 stuff. And I wish I could be recording all day, but I got projects to work on and a bunch of things, so unfortunately I'm kind of limited to how much recording I can do every single day. But for the most part, there's a lot of videos that are available on this channel. You can come over here and you can click on this little search button right here so that you can search for Wireshark videos and everything else that we got. And of course, drop a comment, because the comment section is one of the most important pieces of this entire thing for me. And there's a lot of questions that come in and I answer them. I respond to literally every single comment that comes in. So I'll answer your question inside the comments. If it's a short question, if it's a big question, then I'll go ahead and create a video in response to your question, and it'll be useful for the rest of our community as well. So they got a lot of good things that are lined up here. We got a lot of good stuff, so there's a lot of content that's already scheduled that I'm very excited to actually share with you guys. And as we move along, there's just going to be more and more stuff that's going to come in. And of course, if you have not already checked it out, I would highly encourage you to check out Hackaholics Anonymous, which is the premier YouTube community for security professionals and hackers. There's a lot of great perks that are attached to this community. The community is very supportive of each other, and they're very helpful to each other. So I think you will just enjoy being a part of that community. The Discord chats are amazing. We have Python automations that we give away. There's bug bounties that we go on together. There's exclusive content, exclusive downloads. There's discounts on merch. There's live streams with me. There's a lot of good stuff that happens inside of this community. And if you click on read more right here, it'll open this up for you in a full screen. And if you don't want to watch the entire video, which is literally, it's just like 14 minutes long, so it's not a long video, but the video itself describes all of the perks that are attached to it. And as we go through everything that's available inside of these perks, you can get to figure out what you would get. If you don't want to do that, you can just read through the perks in the description down here. And it's very important for me that you understand what is available to you so that you can choose exactly what is right for you. And if you don't want to join right now, bookmark it for the future, save the video, and just make sure that you come back to it whenever you are ready, because Hackaholics Anonymous is my pet, not my pet project, it's my passion project. It's something that I'm super excited about, and I am already dedicating a lot of time and energy to it, and I think you will like it. I think you'll be very impressed if you come into our community and see what we have available for you. So that's all I got to say about that, and we are officially wrapped. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker / protector. If no one else loves you, Hank loves you. Love, peace, and chicken grease, and I will see you in the next video. Later.